let's talk about rPath's approach to solving IT automation. We have two foundational principles. One is the model, and the other is version control. So those are a little abstract. Let me break it down to what this actually means. If you go into any IT environment, there's some server in a rack somewhere that's doing something. Your organization knows what that system is supposed to look like. It knows what operating system version is supposed to be there, what patches are supposed to be there, what middleware should be there. It knows how the application should be configured. It knows who's allowed to touch it and who isn't. But all that knowledge is spread in people's heads. It's in spreadsheets, it's in little databases, it's in text files, it's in change tickets. It's spread all over the place. So everybody knows that your organization should know how a particular system should look, but it's not explicit, so you can't use it as a basis for automation. You can't say, go make sure the system is the way it's supposed to be, because that information is in people's heads. The second piece is version control. And what this really means is dealing with the onslaught of change. The software development community has figured out over the past 10, 20 years that instead of trying to stop the massive flow of change and lock files and say, okay, only one person at a time can change a particular piece of a program, they said, if we had a tool that could just deal with lots and lots of change, then things could get much more fluid. I can let every developer can make changes as fast as they want, and I'll let my automation system downstream merge different changes together and log what's happened in what orders, and maintain things like branches where I put some changes in one version of the product and other changes in another. Really, version control is a technique to deal with the massive flow of change that's coming into any complicated system. So this is, at an abstract level, this is our approach. Come up with an explicit model for how a system should look, and use version control to deal with the massive onslaught of change, right? But now, so what does that actually mean? What do we do with this? So where does the model actually live when you're using rPath? So I'm going to draw rPath as a big box. This is our on-site software that you buy and install on-site. And I want to draw the models over here. And in rPath, we call the model for a system a manifest. And just like a shipping manifest that tells you everything that's in a package that got shipped across country, a system manifest in rPath tells you everything that belongs on a particular system. It's that explicit model I was talking about. And these manifests are versioned. So let's say this is the manifest for my web server. It tells me everything that should be on a particular web server. Right? I've got my web server manifest. It's versioned. So I know that my version 1.1 of my web server looked like this, and 1.2 looked like that, and 1.3 looked like this. And in order for us to actually know everything that belongs on a system, we need to have all the artifacts that go into a system under version control as well. So let's say I've got HTTPD, I've got version 1.5, and 1.6, and 1.7 of my web server. I've got different versions of the operating system. So let's say it's Red Hat Enterprise Linux 5. Here's Red Hat Enterprise Linux 5.2. I might have different configurations. So the config file for Apache, I might have httpd.conf. I've stored a particular config file that I like and gave that a version number of 3.7. And then 2 weeks later, I changed it a little bit. So I have the same config file, but now we're storing a different version of that, say 3.8. What a manifest does is tie together combinations of all these artifacts. So maybe back in 1.1, I was using this combinations of artifacts. And then somebody said, oh, we've got a problem. We need to change the config file. So we'll keep using the same version of Apache and the same OS, but we'll update the config file when we went to the version 1.2 of the web server. And then 1.3 came along. We said, no, it's time to actually upgrade Apache. My build people have put together their own custom build of HTTPD that does everything they need. So let's upgrade to that, but keep everything else the same. Okay? So This is, if you look inside the very core of rPath, you take away all the GUIs and the stuff we do to make it a usable product. Deep down underneath, this is what we do. We have a deep model called a manifest of everything that belongs on a system. We have versions of every artifact that go into a system, and we tie those together so that we can describe a system completely. So that's the model. Now, of course, the real question is, what can you actually do with that? You know, a model's neat, but what can I actually do with it? There's 4 really key things you can do with a manifest. And once you understand this, you'll be able to see how rPath can actually start to address these various automation problems. The first thing we use a manifest for is generating images for rapid provisioning. So what we can do is grab a version of a manifest and generate dynamically a VMDK to go deploy on VMware, or an AMI to go deploy on EC2, or a CD-ROM image that when you boot will go lay down that manifest on a bare metal physical server, right? So for any physical, virtual, or cloud target you want to use, we can dynamically generate a provisioning image from the manifest that will go build a system that looks like that. And all these decisions are baked into the image. So provisioning is now a one-step operation. Go grab the VMDK out of rPath and deploy it, and everything's configured the way I want. It has all the patches I want. Everything I want in that system is baked right into the image. And you don't have to keep these images around. One common approach to scalable provisioning is the golden image approach, where I have a special system that's kept exactly the way I want manually, and when I want to provision, I make a whole bunch of copies of that image. The problem is that when you're dealing with the onslaught of change, all of a sudden you need lots of golden images. One is not enough. Just like in our model where you have many, many, many manifests, because they're cheap, they're just objects in a repository, with the golden image approach, you have to manually maintain all these images. And that turns out to be a real pain. We believe that images are ephemeral. You should be able to throw them away when you're done. Because if you ever need one back, you can just go ask rPath and say, go grab 1.1 of my web system from 3 years ago, and generate me a fresh VMDK, because I'm getting audited and I need to go do some tests on that thing. We can regenerate these images on demand given a version number. So that's the first thing you can do with a manifest, is solve the provisioning problem. The second thing is solve the update problem. So let's say I've built an actual computer. Let's say it's a physical x86 server, and I put version 1.1 of my web server manifest on it. And it's sitting there humming along, it's working fine. Now I've decided that it's time to upgrade to version 1.3. So I can create new 1.3 web systems using the image. I'll just go provision new ones. If I want to upgrade the existing system to 1.1, our approach is don't worry about yourself, all the individual changes that need to happen to get from 1.1 to 1.3. Just as a software developer would let the source code control system figure out how to merge someone else's change into a program, let your automation system figure out how to get that system from 1.1 to 1.3. So what we do, you ask rPath, hey, please update the system from 1.1 to 1.3. We dynamically look at the current state of that system, including any drift, if maybe somebody installed some packages out of band. And we figure out on the fly what needs to happen, the delta that will take that system from 1.1 to 1.3. And that change is incremental and it's minimal. We don't blow away the system with a fresh copy. If really just a couple things change to get from 1.1 to 1.3, because we have this deep model, we can figure that out. And we'll say, oh, well, what actually needs to happen is the config file needs to go to version 3.8, and HTTPD needs to get upgraded to 1.7. And we will send down from rPath the minimal change that, when applied to this system, will get it to that. And that is a really efficient and scalable way to update many, many systems. If I've got 1,000 systems and they've all drifted a little bit, they might be a little different. just trying to come up with a single change and apply the same change to every system isn't going to work. I need automation that can look at the systems, figure out how to update each one of them to get to my new version of the model. Okay? And by the way, we're doing provisioning and updating from the same model. We're not using two completely different tools for that. We're using one model that gives me both provisioning and updating, which cuts out half the work. The third thing you can do with a manifest is handle compliance. Compliance. So with most tools, compliance is a completely separate tool set from provisioning and updating. I might use Kickstart to go build my systems and Yum to update them, and then I'll go grab an open source compliance framework that runs scripts to go check various things to tell me whether I'm compliant with a particular model. When you have a comprehensive model, it's not a partial model, it's actually a complete model for how a system should look, compliance is easy. All you need to do is compare a deployed system against the manifest. And we have automation that does that. So you can ask rPath, do a deep inspection of the system, look at every file, look at every config, look at the version of the kernel that's on that system, compare it to the comprehensive model of a particular version, and tell me all the differences. You'll get a list of differences, and we can remediate them, bringing the system into line with that particular manifest. Or we might even want to adopt them. Maybe those differences are good, and what I really want to do is capture those differences as a new version 1.4 of the model, so I can duplicate it out to other systems. Right? That's our fundamental approach to compliance. And again, it's completely unified with the way we do provisioning and updating. So the fourth thing, and I promise you this is the last one that I can do with a manifest, is do lifecycle management. So like any good version control system, these aren't just versions floating in space. They're associated with a particular development stage. So maybe 1.1 was on development, 1.2 was also on development, but 1.3 got promoted to testing. That's explicit information inside the rPath model. So I can take from build to test to production, I can take an entire system build. I might take 1.3, do some testing on it. Here's 1.3 again. Now I'm ready to deploy 1.3 into production. So I changed the metadata. The model now knows that 1.3 is available for production. And because this model can't change once it's in the repository, these things are immutable. Like any good version control system, once it's checked in, you can't go back and fiddle with it. It's locked down. I know forever exactly what 1.1 means. That's how we solve the problem of keeping things consistent as we go through the lifecycle. If I look at a 1.3 system that's in my dev environment and a 1.3 system that's in my production environment, I know they're exactly the same because that version came out of the repository. So in a nutshell, that's our approach. Keep an explicit model, version control all the artifacts that go into the model, and then use automation to solve all the fundamental system administration tasks like building new systems, updating existing ones, checking for compliance, handling my development lifecycle. Base all of that off the model, and that's our approach to make automation scalable.